This is Geometry, Semester 1, Final Exam Review. We're looking at Unit 1. And we're supposed to give two other names for line AC. You know this is line AC because of the little arrows that are on either side. Well, line AC is here. You can pick any 2 points along that line, and we can put arrows. So line AC, you could call it BC if you wanted to. We can also call it line K because it's a cursive letter. That K is represented for the whole line. Name 3 points that are collinear. Collinear are points on the same line. So A, B, C, they're considered collinear, or even E, B, F. Another name for plane P. Look in the corner, you see the P. There's no dot near it. It's actually a little bit more bold letter than the others. So that's just naming this plane. Another way to name that plane is any 3 points that are non-collinear on that plane. So you'd say plane ABD, or you could say plane BCD. If you name them collinear, then there's actually an infinite number of planes that contain that. You have to hit the non-collinear, and D is the only point in that plane that isn't on line K. What's another name for ray CB? Well, because it has a beginning point, which we actually call it an endpoint, at C, and goes through B, you would hit the same locations if you started at C and went through A. So CA with the arrow above it. 2 pairs of opposite rays. Opposite rays have to go in opposite directions, and together they form a line. There's no overlapping points except for the endpoint has to be the same. So one set you would have would be from B to A, and then from B to C. They have the same endpoint and they go in opposite directions. Together they form a line. BE and BF. Name another name for line EB. You could say EF. You could say BF. You could even say line L. Name the intersection of line L and line AC. Line L is here, line AC is there. They share this point B. Point E is between DF on segment DF. So let's draw a picture. DF, and E is between it. We don't know where it is between it, it's just between it. It could be in the middle, it could be anywhere, closer to D, closer to F, who knows. We know that DE is 5x minus 3, EF is 3x plus 5, and the whole thing is supposed to be 66. So looking at the information they give us, we can't say that the two segments are equal to each other because we don't know that E is the midpoint. But we can say that those two pieces together have to equal the whole thing. So DE plus EF equals DF. That's a segment addition postulate. So we get 5x minus 3 and 3x plus 5 has to equal 66. Together that gives us 8x plus 2 equals 66. Subtract the 2 to get 64 and divide by the 8, and x actually equals 8. DE is going to be 5 times 8 minus 3, which is 37. And EF is going to be 3 times 8 plus 5. 24 plus 5, 29. And together that adds up to be 66. Segment bisector line AB bisects CD. So we have CD. It has a midpoint here. We have this other segment that's bisecting it at point B called AB. And we're to find CD if BD is 5 1/4. Well, if AB is the bisector, segment bisector, we don't know if it forms 90 degrees or not. My picture kind of makes it look like it, but that's not the point here. The point is that B is definitely at the midpoint. So BD is going to equal CB. Therefore, if BD equals 5 1/4, then CB equals 5 1/4. CD is those two added together. So 5 1/4 plus 5 1/4 makes 10 2/4, which is 10 1/2. The endpoints of two segments are at these locations and those locations. Find the segment length. Well, if we're finding length, then we're going to do distance formula. Be sure you know the distance formula. So here would be your x, maybe x1, y1, x2, y2. So when we plug it into our values, we're looking for BC. We're going to get 3 minus 5 for the x's, negative 7 minus 1 for the y's, this is the square root of 68. Now, for us to know if it's congruent to the other segment, we need to find out the distance of EF. Again, We'll call this x1 and y1, x2 and y2. Notice that when you subtract a -3, you need to put parentheses around it. Five and 3 is 8. 8 squared is 64. So 8 squared is 64. So together that equals 128. So find each segment length. We did that. Tell whether the segments are congruent. They are not congruent. BC is congruent not congruent to EF. Find the midpoint of each segment. So the midpoint formula is the average of the x's, comma, the average of the y's. So for BC, that would be 5 plus 3 divided by 2, 1 plus -7 divided by 2. That's 8 divided by 2, which is 4. Then it's -6 divided by 2, which is -3. That's the midpoint, the halfway point in between BC. We also have another one, -3 and 5. One and 9. -3 plus 5 is +2. Divided by 2. 10 divided by 2. So we have our other midpoint. Notice how the midpoints are not at the same place. Different midpoints. M is the midpoint of this segment. So if it's the midpoint of the segment, then we know that on both sides are exactly the same. So we know that GM is equal to MJ. So we can say that 4x minus 3 has to equal 2x plus 4. Notice for this one, they don't give us a total length like they did on number 8. They tell us in this case that M is the midpoint. So we know those two segments have the same length. So x is going to be 3.5. Let's check our work there one more time. 4x minus 3, 2x plus 4, subtract, add. Looks good. So to answer the question, you know that 3.5 is going to be an answer on the test, but 3.5 is not the answer to the question. GM is 4x minus 3. So we need to say 4 times 3.5 minus 3. That's 12 and 2, which is 14. So we're going to get the answer of 11. Number 12. Find the coordinates of the other endpoint. Well, there's two different ways to do this. Think about an XY axis. If you were to plot the points at 2, -3, and plot the points at -6, -4, if that's the midpoint, we know that the other point is down here somewhere. Notice that we're over 2 this way, but we're backwards 6 this way, so this is a total distance of 8. So I need to go 8 more to get out here. So -6, that's where we are here, and 8 more that way gives us -14. So, figuring out up and down, we have to go down 1 to get even with the m, so we have to go down 1 to get even with our new point. So if we're down 1 extra past m, we're going to be down at -5. So -14, -5. That's one way to do it. There's a mathematical way that we can use a formula. We know that x1 plus x2 over 2 has to equal the x midpoint. So we know this is your midpoint. So the x that we know is 2. We don't know what the other x is. And we know the midpoint is -6. So multiply by the denominator to get -12, subtract 2 more, and get -14. That's why that matches. You can also do it with y1 plus y2 over 2 equals the y coordinate of the midpoint. So the y is -3 plus some y number divided by 2 has to equal the y of the midpoint. The y of the midpoint is -4. Multiply by 2 to get 8. Add 3. When we add 3 to -8, we get the number -5. So we've got -14, -5. Same thing that we did as we counted our way through this problem. The problem with counting is you need to know which way you're going. You need to understand which one's the midpoint, which one's the end point, for you to know which way to start to do your calculations. For number 13, we know that the measure of JKL is supposed to be 70 degrees. So I know that the measurement of angle JKM and the measurement of angle MKL is supposed to be the measurement of angle JKL. JKL is 70. The measurement of MKL, 4x plus 9. And JKM, x plus 31. So add our like terms together, we get 5x, we get 40. Subtract the 40 across. Divide by the 5. x equals 6. 6 is most likely going to be an answer on the multiple choice test. But be sure to answer the real question so you can get the problem right. We're looking for MKL. So 4 times 6 plus 9, 24 plus 9, 33 degrees. On the next page, we know that AB bisects CAD. If it bisects it, then we know that the measurement of angle CAB has to equal the measurement of angle BAD. Those two have to be the same. So 5x minus 80 has to equal 2x minus 5. Collect your like terms. So we know that x equals 25. It says write and solve an equation for x. So he answered the question. Use the picture to answer the following questions. Find the length of the segment. If you notice closely, we're going from this point, which is at negative 15, out to this point, which is at 25. So you could either count 5, 10, 15, 20, 25, 30, 35, 40, or you could take the negative 15 minus the 25, put that in absolute value bars, and you're going to get 40. That's the total distance. So that's the length of the segment. If you begin at the leftmost point, what coordinate is 3/5 of the total distance? Well, we need to break this up into fifths to figure out where 3/5 is located. So we're going to take the 40, multiply that by 3/5, and you make this into a fraction and multiply straight across. So you get 120 divided by 5. And 5 goes into that 2 times, with 2 left over, goes in there 24 times. So we need to do 24 points. So one way to think about that is negative 15, because we're supposed to be at the leftmost point, the one on the left, and add 24 to that. Another way to look at that is to start at negative 15, 5, 10, 15, 20, 25, one less would be 9. So we would be at the coordinate of 9. If you begin at the rightmost point, which coordinate is 1/8 of that total distance? Well, start out with 40, multiply by 1/8. You'll probably want to put this as a fraction and multiply straight across. So 1/8 is a length of 5. 5's not your answer. So we're going to start at the 25, and this time we're going to the left. So we're taking 5 away. We should land at 20. And if you look at the graph of that, 5 to the left of the rightmost point is 20. We're going to use the picture. Is the backboard perpendicular or is it parallel to the ground. The backboard is this portion. The ground is here. A backboard is perpendicular. The plane containing the rim. Now the rim, think about putting a piece of paper or a flat surface on that rim, cover up the rim, and that's going to be level, parallel with the floor. So parallel to, is the rim perpendicular or parallel, oh, to the backboard? Sorry, it's parallel to the ground, but it is perpendicular to the backboard. So it's important to read the question, perpendicular with the backboard. Last question, is the plane containing the rim perpendicular or parallel to the ground? Here it is. It is parallel to the ground because they're both running at the same direction. The rim is a circle, the ball falls through, and the ground, it comes and bounces on it. That's Unit 1.